Hello everyone, Dan here for Waygate Technologies, and I have another installment for you for the USM 100, our new portable flaw detector. Today I'd like to show you a little bit of a special application. We've had some questions about how good is the pulsar in the USM 100, and a good way to show that off is a low frequency application with a very large diameter probe. In this case, I have a rubber step block here with steps at 1 inch, 2 inch, 3, 4 inches. And I have a very low frequency probe, a 500 kilohertz probe, 1 inch diameter, that's well suited to penetrating through this very attenuative rubber material. And one of our classic instruments, the USM60, was our previous benchmark for this test. It had a 450 volt pulsar, square wave pulsar adjustable out to 1,000 nanoseconds, 1 microsecond pulse width, and it was well suited to this application. On the screen I have frozen the signal from the instrument optimized for setup with this probe and looking at the 4-inch thickness of the rubber step block. We won't go through the full setup for that. We'll go through the USM 100 setup here in a few minutes. But that gives you kind of a reference signal. You see the echo at 80% full screen height, actually a little over about 90%, and gain set at 88.5 dB to accomplish that. Over here on the USM 100, I have also optimized setup for that. I have the display frozen, again with the 4-inch echo. Gain here is set to 71 dB. On the USM 100, we'll see in a minute, even though the pulsar voltage doesn't go quite as high, it tops out at 350 volts as opposed to 450. That's only a dB or 2 difference to start with. However, on this instrument, we can set the pulse width as wide as 2.5 microseconds, 2,500 nanoseconds. So we can deliver more energy to the crystal with USM 100 than we could with USM60. That coupled with a good low frequency filter in here. We have a filter optimized at 500 kilohertz. And that coupled with the very quiet amplifier that's in this instrument to begin with, really shows off this particular application. So again, on the left, the USM60, on the right, the USM 100. You can see in the USM 100, our noise floor is lower. It's only a couple of percent screen height. We have some acoustic information up front here, but the basic noise floor of the instrument is still very quiet, down below 2 or 3%. Here in the USM60, you can see a higher noise floor. That's about 4 or 5%, a little higher, some of it peaking closer to 8 or 9%. So just overall quieter and making more efficient use of the probe. So let's take this out of freeze mode, and we'll start over from scratch and show you how we set the USM 100 up for this test. So I'm just going to drop out of my app. And we're going to be using the app that's provided with the instrument, the basic conventional app. And I'm going to start that over from scratch. I'm going to choose the launch option, which starts it from the beginning. Let me bring my probe back around here and connect. And for now, we're going to move down to the 1-inch step to aid in our setup a little bit. So a couple of things that we need to do. First thing we're going to do is come in and set up, tell it something about this probe. Okay, so I touch the A scan to open the menus, and I'm going to choose the probe menu to start. We have a flat part. We're going to set our velocity to 0.06 inches per microsecond. I happen to know that the rubber is approximately 0.06 inches per microsecond velocity. Close that. Let's see. We're going to tell it that the probe frequency is 0.5 megahertz. Okay. We're going to tell it that the probe delay is approximately 2.3 microseconds. That's a property I just happen to be familiar with in this probe. And the rest of that menu is fine. Then we're going to go to our A-scan menu. And we're going to tell it that we want 8 inches of display range. That'll be nice for looking at the various steps in the block. Okay, we'll go to the pulsar receiver menu. And the first thing we're going to do is go to manual Prf mode. We want to set our rep rate low because we're using a very wide pulsar. I can scroll down, or we're just going to go right to 100 hertz. Okay, we're going to max out our pulsar at 350 volts. And we're going to take our pulse width to, let's set that to 2000 nanoseconds. So the 500 kilohertz pulsar, one complete cycle of the ceramic is going to be 2000 nanoseconds, 1 over 500 kilohertz, 2000 nanoseconds. Ordinarily half wave, so about half of that would do well. But I found with this pulsar, all the energy we can give this this probe is the best performance that we get out of it. So we're going to call that 2000. And then we're going to close that menu. Let's adjust our dB step a little bit to get some coarse gain steps. We'll take it up to 6 dB per step. And I'm going to come around the back here and hit the gain button. And we'll take that up to 70 or so. One thing we forgot to do earlier was to set it to our 0.5 megahertz filter. We had the filter set way too high frequency. So let's come back down here. Okay. So we have our 1 inch, 2 inch, 3 inch. Let's give it a little bit more gain. Let's go back to 2000 nanoseconds of pulsar width. Okay. Get our B gate out of the way and drag our A gate over here. Let's go auto 80. There we go. And our 4 inch step. Auto 80. I think we have very good coupling here. There we go. We're way high. Let's hit auto 80 again. Adjust back. There we go. Now we're back to about 81 dB. Nice quiet noise floor. 3 inches, 2 inches. So now let's take some of that gain out. We'll go back to our 1 and 2 inch steps, and we will advance to the next panel where we can do a 2-point calibration. So we're going to do our calibration at 1 inch and 2 inch. Take our gain down here over our 1 inch. So now we can swipe out the sidebar. So this is a special feature of the USM 100. We can swipe out the sidebar. And the sidebar menu, it's a special menu that's present on each of the panels, and it has some of the most commonly used controls for that panel right at your fingertips. So this is our 2-point calibration panel for velocity and probe delay. So the two of the most frequently used controls are going to be our reference 1 thickness. What's the thickness of the first step we're going to look at, and what's the thickness of the second. So we're going to tell it we want to look at 1 inch and 2 inch. Okay, and we're going to do multi-step calibration, so I can swipe left to hide that menu again. My gate is already over my 1 inch echo. I can do auto 80 and hit calibration. Now it's telling me to go to the second step, reference 2, with 2-inch. So I can do that, do auto 80, calibrate, and it comes up with 0.0608 inches per microsecond and 2.214 microseconds of delay. So now we have our delay and velocity calibrated. You can see my gate reading up top here is telling me that I'm measuring 2 inches on that step. We get back here, look at our 1-inch step. Get our gain under control. We're back at 0.998, so effectively 2. Okay, move to the next panel. Next panel doesn't help us a lot here. This is auto angle. Since we're doing a normal beam probe, no need for the auto angle. We can take a look here at our eval panel. If we swipe out, I'm going to change my eval mode to DAC because I want to set up a TCG curve to help us even these things out. So I'm going to say I want to do a custom curve, which means I can just pick my points more or less at random. So now I can go ahead and record. So if I do auto 80 on that point, I hit record my first point. I see my DAC curve appear. Go to 2 inches. Do auto 80. Record a DAC point. Again, hit the cal. Go to 3 inches. Here. Auto 80. Cal. And go to 4 inches. Cal. Okay, so now I've got a DAC curve showing steps 1 through 4. And if I scroll down in this menu a little bit and I switch from DAC mode to TCG, now I have a gain curve set up for TCG, which allows me to get a nice echo on any of the 4 steps. It's a little hot there. Okay, so I can take a couple of dB out. I need to choose a little finer gain steps now. So let's go back to half a dB. I'll take half a dB out. There we go. So that gives me pretty usable steps. So there we go. We can hide that menu. So now we have a setup that allows us to take, if I widen my gate here, it's by touching and dragging on the screen. Maybe I want to go to a wider A scan. I think we had 8 inches on our USM 60, so let's set that up the same. Okay, so there's 8 inches. We're at half screen. Go to the 4-inch step. There's my, give it just a little bit more couplant. There we go. Take a little gain out. Okay, there we have, sort of an apples to apples comparison. Move our gate out of the way here so that you can see the echo nicely. Actually, let me bring that back here a second. Hide the menu. Oops. Hide the menu. Do an auto 80. Now we have apples to apples. 8 inches of range, just like on the 60. We have our echo at 80%. We're running live. I can scroll down here, hit the freeze button, and freeze that. So there's a good side-by-side comparison. Hope you enjoyed this. A good example of how using some of the various parameters of the pulsar can be used to really optimize the performance of a probe like this and get through very attenuative materials. So thank you for joining me, and as always, if you have any questions, please reach out to remote service at bakerhughes.com. Thank you.